Nope. Nope. Hello, everyone. Welcome, welcome. I guess I should let people know that we're going to be back on YouTube today, huh? Probably all kinds of people are queued up in Teams. Yeah, I should probably do that. Here, open up Chrome. There we go. How is everybody today? All 19 of you. I know that attendance is usually a little lower after a test, but jeez. Harf, harf, snarfle. Alright. Hello. Hello, Mark. Yes, you need to, you do need to email to confirm an MSAF. Sorry, I've not quite been on top of my email this weekend. I had other things going on, so yes, I have received a whole buttload of MSAFs. I am going to be processing those all in due time, and that's fine. We'll, you know, it will be what it will be. But yeah, if you have submitted an MSAF and you haven't heard anything, it's just because I haven't done anything about them yet. But yeah. The test was rough, eh? Not as rough as it could have been. Aren't you glad there was only that number of questions? Yeah. Anyway. Well, yeah, I mean, you know, if the marks are finished processing, then, well, actually, Mark, if you wouldn't mind holding off on that until I have time to check my email, I think there might be one or two reasons that might, be delayed, but, yeah. Is there any way to go over JSON and assignment 9 questions I'm struggling to understand? Please help. Yeah, yes. Not during this lecture. We need to keep moving on the lecture material. But if you send me an email, then I extended the deadline to tomorrow at midnight. So I'll see if I have some time today. I'll schedule an appointment with you if you like. Maybe we'll see. It's going to be a busy day for me, but you know. Anyway. Bloop. There we go. Let's see here. Where were we? Done dates. We were on SQL, yeah? I think I remember us being on SQL. Well, the thing about that is that I should probably talk on the subject of MSAFs just for a very brief moment. Um, the the MSAFs in general, like that's supposed to be a medical accommodation, right? Or, you know, undue stress-related, mental illness-related stuff. That was the intention of the policy. I know that everybody uses it as a get-out-of-whatever free card, but, you know, it's just a little bit disheartening to me that, like, I set a test and, you know, from rough estimates, judging by my email, maybe like at least 10% of the class MSAF'd this test, and that's just a little disappointing. But, yeah, I think you'll find there's some practice exam material in Avenue if you go look for it. But yeah, anyway, let's move on to databases. Okay. So, I think we were somewhere in this vicinity. Yeah. Okay. So, documents, master, 1MD3, fall, code. Do we have a .db file in here? Movie store. Yes, video store. SQLite 3 video store.db. That's how you open a database, of course. And if you want to look at everything in a table, you select star in movies, for example, semicolons, or from, not in. And there you go. This is the database that we were working on last time in class. So, last time in class, we sort of ended with a review of some of the various techniques that you may use in order to select, basically format the data that you're viewing when you select something from a database. Most particularly, you can do some fuzzy matching, but we'll just review this quickly. Select star from X, where X is the table, will just display you the entire table. If you wish to view some particular category, you may have a comma-delimited list of those categories, and it'll show you just those elements. If you wish to filter your results, you may also do so. No such column where genre is equal to comedy, in quotes. There are none, but if we insert the %sign tag operator to do some fuzzy matching, then still nothing. Interesting. Did I misspell it? Well, anyway. Oh, no, you have to use like rather than equals. Pardon me. There you go. So these are all of the movies that have comedy somewhere in their genre, which is a good thing to know. And of course, if you want to order them, you have the order by tag, which has the, you can select which of the different columns you want to order it by. For example, title in ascending order. And there you go. So these are your various options for displaying information. We have to specify 4 things: which fields to return, which table to return it from, which rows to select, and in what order to sort. So there you go. So, thank you for answering all of these questions, Mark. So it turns out that you can actually execute all of this stuff from inside of Python as well, not just through your SQLite interpreter, which operates very similarly to the Python interpreter. So let's open up a Jupyter notebook, and we'll try some of this stuff out. We'll just do it at the bottom here. So we can, in fact, there we go. We can import the SQLite 3 library in order to imbue Python with the power of database management. Database equals SQLite 3.connect video store.database. And just to be on the safe side, we'll close this guy off. I think it's .quit, actually. There we go. So, in the same way that a file stream requires you to open a file in a particular mode and then close the file stream when you're finished with it, databases are the same way. You also are required to close the things down once you're finished with them. So, whatever you do, in the middle, you have to end with dd.close. This is a, so when you convert between Python and SQL, obviously the data types don't quite line up completely, so this table should help you a little bit. Null is the same as none in Python. Integers are ints, reals are floats, texts and dates are both strings in Python. I would, and you know, to some extent in Python the idea of data type is somewhat ephemeral anyway, but you should get used to the idea of things having hard data types if you want to program in any other language. So, if you would like to execute a very basic command in SQL, what you have to do is you have to open up a cursor. So cursor is equal to database.cursor. So cursor is the cursor is very similar to the command prompt here. You can think of them as being the same thing. You feed instructions into them, and you receive back from them results. And because this is sort of an encapsulated process, you have to manually view all of the things that you that SQLite puts into the cursor object. So cursor.execute, select star from movies semicolon, print cursor dot fetch all. And there you go. Very quick, simple, easy. There it is. Notice the format in which this data has been returned to us. This is a list of tuples, where each tuple is a record in the database. That's an important thing to note. If you want to print it a little more prettily, you could do something like for, or I think we're going to do this in a couple of slides, so I'll just leave it like that for now. Yes. So if you want to just take the return type rather than fetching the results directly from the cursor object, the return value of the cursor.execute method is in fact the same data, and it is an iterable object, which means that we can use for loops. for row in rows, not that kind of rows, print row. There you go. That prints it all on its own. Each thing gets its own line. So there you go. Very cool. Let me see if we have any questions. Does Python only support SQLite, or does it also support other variants of SQL? Yeah, the thing you'll find, Paul, about Python is that it's a popular enough language that has enough people working on it that normally you can find something in Python for any particular thing you're looking for. So, you know, the answer to some extent is to just noodle around a little bit, see if you can find the particular version of SQL in this case that you would like, and, yeah, just include it. SQLite 3, this is a very particular implementation of SQL, the one that we're using in class, but yeah, it's absolutely probable that it would make a lot of sense for a Python script to be able to interact with a remote database. So, yeah, I'm gonna imagine that exists somewhere in the planet. So, cool. So we can also insert values into. This is just, viewing things, but we can also perform all of the other database manipulations that we're used to, including inserting things into the table. It's really cool because all you have to do is put like a well-formed SQL query into the string, and this method will just execute it for you. So insert into movies values. Huh? What? 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 That's what I imagine a question mark sounds like. And then a tuple with, let's say, 17 Beauty and the Beast animation musical comedy, sure. Rating R. Lol. There we go. So that happens. No return value, since this is a, that's not a function that returns anything. However, if we want, we can then view the modifications to our database post-fact. And you can see that to the end of it, Beauty and the Beast has been added. Ta-ra! So, these question marks here, these act as placeholders in this string. So the method automatically scans that string for any question marks that appear in that string, and it interprets that as, oh, so you'd like me to put the first thing in that tuple into the first hole, the second thing in the tuple into the second hole. The thing, it's correct to think about these as being holes in the string that get filled, pardon me, by the values you provide down here. This is actually reasonably similar to the idea of formatting tags in a programming language like C. However, Python likes to remove that stuff for you to some extent. If you think way back to when we were displaying all of the trailing decimal places on floating point numbers, we were doing similar things of leaving holes in strings and formatting them in particular manners. So, that's fine. And we're going to get into why you would want to do it that way a little bit later on. But it's important that you do it that way, rather than just performing the direct string manipulation yourself. So let's talk about the relationships between tables. We'll leave this guy to rest for the moment and go back to our SQL interpreter. So let's suppose we want to keep track of which customers rented which videos. Well, we already have our database of videos. We'll need a database of customers, and we will need some table that keeps track of the relationship between customers and movies. In the context of, if this were a real system, that would be the database of movies. That would be something that would be generated by the employees who are responsible for the intake of the movies, right? When you get new movies into your collection of movies as a video store, you enter them into the database. If any movies become damaged and have to be removed, then that also becomes a function of that employee. The customer database would be maintained by a sort of frontline employee who sets you up with an account at the movie store so that you can rent movies, and the relationship between customers and movies that would be encapsulated in the point of sale system, which would keep track of which movies were rented to which customers at the time the customers were renting and returning the movies. So there you go. That's how this would work in real life. So let's load SQLite once again, and let us create table customers. Yes. And the schema that we will have for the customers is we shall have a customer ID, a name, and an address. So I'm going to probably enter a few of these quickly. So customer ID, integer, primary key, name, text, required, address, text, not required, because we're okay renting to people without addresses, I guess. Yes. So, insert into table, into customers, values, 101, Dennis, Boardwalk. There we go. Select star from customers. There we go. So it's working. 102 will be Doug, living at Park Place. If any of you are wondering where these are coming from, those are spaces on the popular board game Monopoly. Pacific Avenue. Amy lives in St. James Place. Incidentally, if you want some tips for playing Monopoly with your favorite professor, I am aware of the singular most probable winning strategy, according to me, for Monopoly, and that is you gotta get the orange spaces. You gotta do whatever it takes. Get those orange properties. They are the optimization point between the money you require to invest in houses and the profit gained from said houses. If you own the own the oranges, you own the game. That is my Boardwalk and Park Place might be able to take someone out in one go, in one hit, but the investment required to get them up to hotels is way too high and impractical for the length of most games. Whereas oranges, they only cost $100 each to get houses on them, so you gotta go for the oranges, man. Not to mention, they're most probable hit for anybody who lands in jail, so they're very high probability of being landed on too. So there we go. There's our database of customers. Bloop. There we go. Now, let's create another table for the customer ID, or for the relationships. This will be our rentals table. So create, how does it go again? Create table, rentals, customer ID, integer, required, movie ID, integer, required, date rented is a date, and date due is also a date, and insert into rentals values 103, 104, These are pretty short-term rentals, geez. There we go. Let's just take a look-see. And there is our database of rentals. Very good. So, this is fine. This is good. But what's, like... So how do we work with multiple tables? That's essentially the thing we're working towards here. The customer IDs in this rental table and the movie IDs in this rental table, what we want is for these to be essentially items that we can use to look up the particular elements in the customers and movies databases in those tables, and, you know, pull the data in together and have it correspond to itself so that, you know, when we look up all of the movies that are rented, we can see the titles and stuff like that. So, if we do a select on the rentals table, we only get the customer ID and not the customer name, etc. And only the movie ID, not the movie name, etc. Naively, we would have to do an extra select to look up each customer one at a time, but SQL provides a way to do this all at once. Keep in mind that this is a database, right? Especially if you're working on a remote database, you're not necessarily going to have this nice, pretty little pretty GUI to be able to view all of the elements in the database all at one time, right? You might have to actually enter a command to look up the elements in a database. So, it's quite simple. You can, delimit a number of tables when you select. So, let's just see how it looks without any modifications on it. Select star from movies and rentals. Always forget the semicolon, geez. So this is interesting. This is quite a large thing here. So this is a very important point to the understanding of how SQL works as a system. when you say, I would like, I would like you to display everything in 2 tables, what it does is it displays the second table once for every entry in the first table, right? So it has the entire rental table is tacked on to the first entry in the first table, the second entry in the second table, etc. So what it's doing is it's generating all of the possible combinations, like from a from a combinatorial perspective. We have all of our bases covered. So in order to get meaningful data out of this, you have to restrict this. You have to take this and you have to restrict it down to that information which is meaningful. And you can imagine, if we had larger databases that we were working with, this could become quite cumbersome. So the way that we restrict it is with the where statement, where customer, or actually where movie ID, movies.movie ID is equal to rentals.movie ID. Notice that we can address the various fields in a particular table using dot syntax. There we go. So we can see that the only element in the movie, the only element in the movie table that actually has a corresponding entry in the rental table is movie number 104. The other ones, if you take a look, 5022 doesn't actually exist, and 107 also doesn't exist. So there you go. Now, you may be noticing something, because hypothetically, we were modifying the same file from the Python file, so why is Beauty and the Beast not in here? Well, that's a good question. And the answer to that question is that you actually have to... there's one more command that you need in Python to actually write your changes into the file. And I believe it is commit. Well, let's just see here. That's like saving .commit. There we go. Oh, attribute error. Has no attribute commit? It's got to be in here somewhere. Commit. Yeah. Use cursor.commit to ensure changes are saved. Well, that's interesting, because it's telling me I have an attribute error. Maybe I need to remove this bit. And maybe I need to quit this guy. Operational error. Database is locked. Yeah, so you can only modify a database from one direction at a time. So because I had it open here, I couldn't open it in Python. But now that I've freed it there, I should be able to do this just fine. Operational error still, eh? There we go. Try her again. Oh, for pity's sake. Well, at any rate, that's fine. So, let's see here. There we go. So, what is effectively happening up here is that we generate all of the possibilities, and then we select the cases in which movies.movieid is equal to rentals.movieid. Now, only in one line of this, as it turns out, this guy right here, are these two fields the same, right? There and there. So that means that we only get one entry that is produced. However, we do get all in one data dump, the name of the thing, and the dates on which it was rented and due, and the customer ID of the person who has rented it. Now, you can go one step further with this and include the customers as well, and you can see that it does the same type of iteration here. So we will add one additional requirement, and customers dot customer ID is equal to rentals dot customer ID. There we go. And now we get the movie, the rental information, and the information of the person who rented it. There you go. The result is as if we had a single table with rows from each table joined together when they match the customer ID field. This is also called a join operation or an inner join. Yes, and this I have demonstrated. So, here we're going to run down a number of the various operations that you can perform on SQL databases right here, right now. We can update fields in one or more rows using the update command. We can specify which fields should be changed and which rows the change should be applied to. Now, this is a tricky thing, because if you don't carefully select the things that the update is going to be applied to, you can very easily overwrite a great amount of your database all in one step here. So pretty much all of these operations are be careful when you do this. So, for example, if in let's see here, can I move this thing up? Oh, okay. If I wish to update movies, set genre equals horror, rating equals R, where title is equal to Monsters, Inc. I think that's how I spelt it. It's got a dot. There we go. Database is locked. Oh my god. Oh my goodness. Have I locked the database from two different directions, and therefore defeated myself being able to do anything to it? Oh my goodness. It's terrible. Okay. Are you locked? Doesn't seem so. Let's try this again. Update. Movies. Set genre equals horror, where title is equal to Monsters Incorporated. That seems to have worked. And you can see the change has been made. There you go. Again, if you don't specify this where clause here, then you end up doing some very terrible things. It'll just apply that change to all of the elements. Now, it is improbable that you would want to set every record's field of a particular, it's unlikely that you would want to set all of these to horror. Probably this is blowing out useful and important data, and that's probably not a thing that you want to do. That's why you should always back up your systems, folks. This change is permanent. It can't be undone. There's no undo in SQLite, at least. There probably is in more sophisticated databasing applications, but in, especially if you're sort of doing these types of transactions on a remote server, it's also unlikely that you would be able to have undo functions, because that's like just not a thing, Yeah, so that's update. You have to be very careful. If you wish to delete, you can also delete from a table, just like you can insert. So delete from movies where movie ID is equal to 104. And you can see that entry number 104 has been removed. So far, so good. Once again, the particular entries to be removed are selected using a where clause. So, if you don't use a where clause here, if you forget to do that, then you'll actually delete every row in your table, regardless as to what it contains. So, recommended to use the where clause there as well. There is no undo. If you wish to delete an entire table, my goodness, then you have the drop table command. You should also be careful with this one, because this is just, it'll delete it, you'll have no longer any access to it, and that'll be it. db.commit, oh, possibly, yeah. That might be an error in the, yeah, let me try that, actually. db.commit. Probably still locked. Yeah. Let's try this one then. Yeah. There, terminated execution. Yeah, so it's database, not .commit, .cursor.commit. Yeah. What if a different tables have the same column name? Won't that be ambiguous? Well, no, actually. It doesn't really check that. So, in our example, we're using customer ID and movie ID. Those both are the same across the customers and rentals databases and the movies and rentals databases, respectively. So, yeah, we're already using tables that have shared field names. So, there you go. If we don't have any similar columns, we can still perform the join operation. Yeah, well, you can still match on, you could definitely still match on things that aren't the same name, right? So, in this case, we have movie ID is equal to movies.movie ID is equal to rentals.movie ID. However, if you wanted to compare movie ID to customer ID, I'm not sure that would be meaningful, but you can certainly do it, right? But yeah. Good, good, good. So, drop tables. What if we want the user to input inside of a query? For example, What if we want to search for all the movies with a particular rating? Here's one thing that you can do. In Python, this is in Python now, you could prompt the user to enter a rating they'd like to search for. Store that rating as a string in rating. Then cursor.execute, select star from movies where rating is equal to the rating. Then print the rest of it. This would end up making a query like select star from movies where rating is equal to PG. Sure. However, this is problem. This is problem, big problem. This is not a good way of going about it, as we're going to see. What if the user includes in their rating here a character that we didn't expect? What if they include, for example, a quotation mark? What we would get is an invalid SQL query, because we'd have two quotation marks at the end here, and that's, that's not valid syntax, just in general. The quotation mark before guidance ends the string, so it thinks that guidance is a SQL keyword, right? So what it does is it says, okay, this is a string, okay, this is a string, this must be a keyword, right here. But of course it isn't a keyword. But I think we have just discovered a way of being able to enter keywords, which is a problem. Even worse, what if the user enters something with quotation marks and then some valid SQL syntax in it? For example, if we enter PG or x is equal to x. So x is equal to x is always going to be true, and if you, something that's always true ORed with something that may or may not be true is always going to be true as well. So that means that this, if you use this as your partial query, then what ends up happening is the user can access the entire database rather than just the elements of it that we were hoping to restrict by encapsulating everything inside of a Python query. So this is the beginnings of what we call SQL injection attacks. So SQL injection attacks are a very, very serious business. When the user's input is mixed into a query like this, the application becomes vulnerable to an SQL injection attack. This occurs when the attacker injects their own SQL commands as a string that accidentally gets executed by the database, or, just gets executed by the database. This can be used for several nefarious purposes. Number one, to see more data than you would prefer that they saw, right? This could include, viewing people's credit card information, for example, because these types of transactions are often stored in databases. You can use trick login checks and gain access without knowing passwords. You can, because, usernames and passwords are often stored in databases. You can be, this can be used to gain access from other tables using join commands, and it sometimes you can even, you don't necessarily have to stop at viewing data. You can also modify the data in the database by using an SQL injection. We're going to talk about the interesting applications of SQL injections and the manner in which you may avoid them next time in class. So, seeing as it's 10:20, about time for us to be wrapping up. Can you put SQL in SQL, a database in a database? You have the ability to store text, right? So hypothetically, you could put the commands that you would require to construct an SQL database into an SQL database in the form of commands encoded as strings. So yeah, in theory, you could totally do that. I'm not sure why you'd want to, but, it's sort of possible but not recommended. But yeah. Are there any other questions? Okie dokie. Well, doesn't look like anybody has any questions. So, thank you very much for your time and attention today, folks. I'll see you tomorrow with more databases and stuff. Take her easy.